जय हे भारत भाग्य विधाता। पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा, विंध्य हिमाचल यमुना गंगा, उच्छल जलधि तरंगा। तब शुभ नामे जागे, तब शुभ आशीष मांगे, गाहे तब जय गाथा। जन गण मंगल दायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Namaskar. Akashvani, India's public service broadcaster, has the distinct honor to conduct every year the prestigious Sardar Patel Memorial Lecture. This lecture is in the memory of Sardar Vallabhbhai Patel, independent India's first Deputy Prime Minister, first Home Minister, and also the first Minister of Information and Broadcasting. This lecture series commemorates the enduring legacy of Sardar Patel, the Iron Man of India, the architect of national integration, a towering figure in India's history, whose 182-meter Statue of Unity in Kevadia, Gujarat, stands tallest in the world. Today, to deliver the Sardar Patel Memorial Lecture 2024, we're extremely honored to have amongst us distinguished space scientist Dr. S. Somanath. May I request Dr. Pragya Paliwal Gaur, Director General Akashvani, to welcome the esteemed speaker by presenting him the Akashvani memento. I request all the dignitaries to step forward. I request Shri Gaurav Dwivedi, Chief Executive Officer, Prasar Bharati, to present a shawl to Dr. S. Somanath. May I request Shri Navneet Kumar Sehgal, Chairman Prasar Bharati, to felicitate Dr. S. Somanath with the special memento created for today's event. Thank you very much, Dr. Somanath. A very warm welcome. We all still remember the inaugural National Space Day this year, which we celebrated with great joy and pride, marking 1 year of Chandrayaan 3's landing on the lunar surface. I request Dr. Pragya to welcome Shri Navneet Kumar Sehgal, Chairman Prasar Bharati, with the Akashvani memento. Dr. Pragya to welcome Shri Gaurav Dwivedi, Chief Executive Officer, Prasar Bharati, with the Akashvani memento. Thank you. As is the Indian tradition, let's light the ceremonial lamp to illuminate our path and spread the radiance of positivity and harmony. May I request the dignitaries to kindly light the ceremonial lamp and thereafter offer floral tributes to Sardar Vallabhbhai Patel as Pushpanjali.
Shubham karoti kalyanam arogyam dhana sampada shatru buddhi vinashaya deepajyoti namostute divya divyare deepatkar कानी कुंडल मोतीहार दिव्याला पाहून नमस्कार तिळाचे तेल कापसाची वात दिवा तेवे देवा पाशी उजेड पडे विष्णू पाशी
31st of October is the birth anniversary of Sardar Vallabhbhai Patel. It is celebrated as National Unity Day. And this year, 2024, it coincides with the Festival of Lights, Deepavali as well. So here's wishing everyone a very happy festive season. We sincerely pray for everyone's well-being and also a sustainable planet and space. I now invite Shri Navneet Kumar Sehgal, Chairman Prasar Bharati, for his inaugural address.
First of all, I remember Sardar Patel on his birth anniversary. One of the greatest men that we had, Bharat Ratna, Sardar Patel. And it's my honor and privilege to welcome Dr. S. Somanath on this very important day. There couldn't have been a better person to speak on one of the greatest men. You all know about Dr. Somanath, that he gave us continuous a proud of moment for all Indians living here and abroad, wherever they were. And it is my honor and privilege, personal privilege, to in fact meet him and honor him here, and I personally welcome him on this occasion. Today, we have another special honor that Her Excellency, Honorable President of India, Draupadi Murmu ji, has also given us a message. It's the first time she's given us a message on this particular day, which will be replayed or played after finishing my speech. I also like to appreciate and thank All India Radio. Sardar Patel, known as the Iron Man of India, he gave us, the geographical unity as a nation. Today we stand, India, we are there, as a geographical union because of effort and his vision of Sardar Patel. As a civil servant, I feel proud to be listening to and speaking about Sardar Patel, because he was the originator of the civil service in this country. Civil service, which is this, called steel frame of India, all across the nation. It was his vision, it was his concept that the civil service in India started. So it is a very rare opportunity that we are all now welcoming another one of the great men, Dr. S. Somanath. You see, over the years, as an Indian, we always been feeling there has been an effort to create a scientific temper in the country. But achievement like these, Chandrayaan-3 landing on lunar surface, that give us confidence, that give us a rare opportunity of, proud all across the globe, proud all across wherever any Indian is living, he could feel proud. And we will have this opportunity to listen to Dr. Somanath about Iron Man Sardar Patel. So I won't take much time. I think the Honorable President's message will replay just now. And once again, I welcome everybody. I am very happy to see this auditorium full of people, particularly younger ones, who need to be more and more oriented towards the scientific temper. Thank you so much, and welcome everybody once again.
Thank you, Shri Navneet Kumar Sehgal, for your inaugural address. इस वर्ष हमारा परम सौभाग्य है कि सरदार पटेल स्मारक व्याख्यान 2024 के अवसर पर भारत की माननीय राष्ट्रपति श्रीमती द्रौपदी मुर्मू जी ने आकाशवाणी को अपने आशीर्वचन प्रदान किए हैं। प्रस्तुत है माननीय राष्ट्रपति जी का विशेष संदेश।
सभी देशवासियों को मेरा नमस्कार। मुझे ये जानकर प्रसन्नता हुई है कि वर्ष 1955 से लौह पुरुष सरदार वल्लभ भाई पटेल की स्मृति में आकाशवाणी द्वारा उनकी जयंती के अवसर पर व्याख्यान माला का आयोजन किया जाता है। इस आयोजन के द्वारा आकाशवाणी ने नेशनल ब्रॉडकास्टर के अपने दायित्व को निभाया है, क्योंकि सरदार पटेल सही अर्थ में राष्ट्र निर्माता थे। भारत के प्रथम राष्ट्रपति डॉक्टर राजेंद्र प्रसाद ने सरदार पटेल के विषय में लिखा था, एंड आई कोट, दैट देयर इज today in India to think and talk about is very largely due to Sardar Patel's statesmanship and firm administration, unquote। सरदार पटेल महान स्वतंत्रता सेनानी थे तथा स्वाधीन भारत की राष्ट्रीय और प्रशासनिक एकता के अद्भुत शिल्पकार थे। उनकी जयंती के पावन अवसर पर सभी कृतज्ञ देशवासियों की ओर से मैं उनकी स्मृति को सादर नमन करती हूँ। स्वाधीनता के समय भारत का लगभग 40% क्षेत्र बड़ी छोटी रियासतों में बांटा हुआ था। उन 550 से अधिक रियासतों में राजसत्ता थी। एकता और लोकतंत्र की दिशा में हमारे देश को काफ़ी लंबी दूर तय करनी थी। काम बहुत कठिन था। बापू ने कहा था कि उस कठिन काम को सरदार पटेल ही कर सकते थे। स्वाधीनता के बाद 13 महीने की अवधि में भारत को एकजुट करने की भगीरथ प्रयास द्वारा सरदार पटेल ने विश्व इतिहास का एक अनुपम अध्याय रचा है। विश्व के सबसे बड़े लोकतंत्रों को एकजुट करने वाले सरदार पटेल के सम्मान में विश्व के सबसे ऊंची प्रतिमा का निर्माण करवाकर प्रधानमंत्री श्री नरेंद्र मोदी जी ने देशवासियों के हृदय में सरदार पटेल के विराट व्यक्तित्व के प्रति आदर को मूर्त रूप प्रदान किया है। राष्ट्रपिता महात्मा गांधी ने सरदार पटेल के विषय में कहा था कि ऐसा स्वार्थ त्यागी व्यक्ति आपको और नहीं मिलेगा। बारडोली सत्याग्रह के दौरान बापू ने सरदार पटेल के असाधारण नेतृत्व को देखा था। बारडोली सत्याग्रह आंदोलन की सफलता को बारडोली विजय का नाम दिया गया। उस विजय से हमारे स्वाधीनता संग्राम को नई ऊर्जा मिली थी। स्वाधीनता प्राप्त होने के तुरंत बाद की उथल पुथल भरी परिस्थितियों में सरदार पटेल ने हमारे देश को एक सुदृढ़ प्रशासनिक व्यवस्था प्रदान की थी। उनकी चट्टान जैसी दृढ़ता ने हमारे नवोदिन राष्ट्र को अनेक कठिन परिस्थितियों से उबारा था। मुझे इस बात की प्रसन्नता है कि इस बार के सरदार पटेल स्मृति व्याख्यान हेतु आकाशवाणी ने भारत की प्रगति में अंतरिक्ष विज्ञान के योगदान से देशवासियों को अवगत कराने के लिए इसरो के चेयरमैन डॉक्टर सोमनाथ जी को आमंत्रित किया है। आज हमारे देश सरदार पटेल के आदर्शों के अनुरूप विकसित राष्ट्र बनने के संकल्प के साथ आगे बढ़ रहा है। भारत की विकास यात्रा में हमारे अंतरिक्ष कार्यक्रम ने अमूल्य योगदान दिया है। पिछले वर्ष विक्रम लैंडर द्वारा चंद्रमा के दक्षिण ध्रुव के पास उतरने का सीधा प्रसारण मैंने देखा था। सभी देशवासियों के साथ मैं भी गर्व का अनुभव कर रही थी। सरदार पटेल हमारे राष्ट्रीय एकता के प्रतीक पुरुष है। आइए सरदार पटेल की पावन स्मृति में हम सभी विकसित भारत के निर्माण के राष्ट्रीय लक्ष्य की दिशा में एकजुट होकर आगे बढ़ने का संकल्प लें। धन्यवाद। जय हिंद, जय भारत, जय हिंद।
We are grateful to the Honorable President of India, Shrimati Draupadi Murmu, for the special message. Sardar Patel Memorial Lecture is an annual feature under the auspices of Akashvani in the memory of Sardar Vallabhbhai Patel. Sardar Patel was an integral part of India's independence movement and one of the key integrating forces of the nascent nation. Every year, we commemorate the birth anniversary of Sardar Patel with the nationwide broadcast of the recording of this lecture, designed to promote awareness on contemporary issues. Over the years, the lectures have become a repository of valuable knowledge for those seeking to understand Bharat. The series began in 1955 with a lecture by the great luminary Shri C. Rajagopalachari. Since its inception, this platform has been graced by eminent leaders, scientists, historians, jurists such as Dr. M.S. Swaminathan, Justice Y.V. Chandrachud, Shri Nani Palkhiwala, Professor Jayant Narlikar, Dr. K. Kasturi Rangan, Justice Leela Seth, and of course, Dr. APJ Abdul Kalam. This year, it's our privilege to have Dr. S. Somanath with us, a distinguished space scientist, Chairman of the Indian Space Research Organization, ISRO, Chairman, Space Commission, and Secretary, Department of Space, Government of India. Ladies and gentlemen, the countdown begins. 5, 4, 3, 2, 1. To deliver Sardar Patel Memorial Lecture 2024 on the topic Indian Space Odyssey in Search of New Frontiers, we now invite the esteemed speaker, Dr. S. Somanath.
Good evening, all of you. It's really an honor to be here to deliver this year's Sardar Patel Memorial Lecture. And I would like to thank Prasar Bharati, its chairman, Sri Naveen Kumar Segal, Akashwani, and all of you to join this prestigious program in memory of the great man that we had, Sardar Vallabhbhai Patel. Let me talk about him a little bit before I delve into my topic of space. Sardar Vallabhbhai Patel rose into the prominence of our political arena through the struggles and tribulations in the times of the independence journey. I think many of us have been already told. But then his leadership really showed up in some of the great movements that we had in the past. The independence that we owe today, we must owe to such great men who created such a strong movement. And not only that he participated in that movement, then his post-independence, he worked hard to create the nation that we all very proud of, the Bharat. I think we have given our due respect to him by creating the Statue of Unity. And we must thank our Honorable Prime Minister for doing that great job of putting such a fantastic statue of him that we all are very proud of, the tallest ever such statue that we have created in a part of this country. We also know Sardar Vallabhbhai Patel was not just part of the freedom struggle, but he created the India today. He has been the promoter of one of the important activity, the liberal policy of the industrial policy, which is that we enjoy today. Also, contributed to bring all the princely states together to create the Bharat that we are all talking about, the political integration of India that we talked about, has already been just mentioned by the chief of the Prasar Bharati, that the whole of the administrative reforms that we talk about today came in his time frame. And we also know him as the Iron Man of India, and we honor him today in his birthday, the 31st of this month. And thank you so much for giving me this honor to speak in his memory today. So when we talk about space, all of you know about ISRO, the Department of Space, but then what you need to realize today is that the whole of the space ecosystem is changing dramatically all around us. So in the fast-changing domain of space, we also are aware that we are also changing so much. The Department of Space and its arms are going through a great reform as announced by the Government of India. The space sector reform announced in 2020 created new entities in Department of Space. The ISRO is well known to you. Indian Space Research Organization is the primary space agency of the nation where the research and development takes place. We created other entities in Department of Space called the InSpace. Today, the InSpace is going to regulate, promote, and handhold the private ecosystem and then create a vibrant space economy. We also have the public sector undertaking NSIL, New Space India Limited, converting whatever we did in the space sector into production of materials or production of rockets, satellites, and also convert into the business opportunity. While we work on these entities in Department of Space, we also have the domains, which goes from building the rockets, we call them space transportation system, building the space infrastructure called the satellite building. We have the human spaceflight program, we have the Earth observation and applications program, and also the capacity building, creating capability in industries, creating capability among academic institutions, researchers. So we work in various domains, working with many stakeholders. Industries, academic institutions is one of the strengths that we have today. But all of us are really excited to see a launch. I don't know how many of you had real fortune to look at a launch of a rocket. it is really very heartwarming to see, or I don't know whether the right word it is like that, the thunderous sound that comes and hits your chest when you hear a launch, and also the beautiful sight of an ascending rocket that goes to the sky to put a satellite in space. It's always a wonderful observation to have you at the Satish Dhawan Space Center. I use this opportunity to invite you. Today, Satish Dhawan Space Center is not closed for you. It is actually open to each one of you. We have a huge gallery. 10,000 people can at a time sit and watch one of the launch that is taking place. So you are most welcome, children especially. Those who are listening to me, please find an opportunity to look at the announcements of launch that is coming up and register for coming and looking at some of these launches. I can tell you that it will raise your spirits very high as much as a rocket soars to the sky. But over the years, we have been launching rockets, we have been placing satellites in orbit. You look at the tally of what we have done is really astonishing. For a country like us, I think when we started this whole program in the 1960s, we were launching small rockets to space while other nations were putting men on the moon. So you know the gap that existed between us and the other nations. And this gap that existed, we have bridged substantially over the last so many years, putting us as a leading spacefaring nation today, having the ability to build our own rockets, build our own satellites, and launch it from our own soil. It's not a mean achievement for a nation like India. And we have done, not only did so many launches, like hundreds of launches and almost hundreds of satellites that we have put in space. We not only did that, we also launched almost 400 plus satellites of other nations using our rockets from India, almost 34 countries. We did a lot of research activities in creating new technologies and innovations in space sector. I think all of these are showing up results now in the form of assets that we have created in space ecosystem. They are in the form of spacecrafts that are there. We have 50 plus spacecrafts in orbit today. So we have this many of the satellites now, along with other thousands of satellites up there. But then it's not just the satellite that we have. We have produced connect to the stakeholders who are actually using this the satellites in a big way. The communication, I think Akashvani and Doordarshan are the users of the satellites in the form of television broadcasting, DTA services. We have connectivity of internet. We have also connectivity to various stakeholders who uses our networks. And we also connect with the many departments in the government of India, the meteorology, the land use, the weather, oceanography, fisheries, the Airport Authority of India, disaster management, and many, many other services that we deliver through space, the backbone of this. We also have the NAVIC ecosystem, which is providing the position navigation timing services called the NAVIC, and of course the science missions of Chandrayaan and Aditya L1. We provide scientific data to the researchers who are interested in space domain to work in the cutting edge of this research. It's not only the spacecraft that we have. The most important strength of a nation in space is the ability to launch it from their own country. Rockets are very strategic assets for any nation. And we started this journey of building launch vehicles when Dr. APJ Abdul Kalam was the project director of SLV-3. We all know the story of SLV-3 development and also the ASLV. I think they are no longer operational. Today we have the operational rockets, the PSLV, GSLV, the launch vehicle Mark III, and the new entrant, the small one, the small satellite launch vehicle. All of them are operational today, and PSLV has done 50 plus successful launches today. A very strong workhorse launcher who has put all those satellites that I mentioned some time back. The GSLV was developed using the cryogenic technology, and the indigenous LVM-3 is the heavy booster that launched the Chandrayaan launcher satellites in the recent times. And it's going to be the one which will evolve to finally put human beings to space from India. The small launcher, the SSLV, is the new entrant I told about. It's a revolution today with at an extremely low cost. We are able to build a launcher and transfer the knowledge of building rockets to the private industry. That's the goal of building small satellite launch vehicle. I can tell you, rocket building is not a small thing. It's a very complex process. And we took almost 60 years to learn the trick. And we have the knowledge of doing it today in Department of Space and ISRO. It's an institutional knowledge which is created over generations. And holding this knowledge, nurturing this knowledge, and keeping it preserved to do future activities in space is very important for us. And this is why we nurture them, we connect with the many other stakeholders like the educational institutions and researchers to preserve this knowledge so that we can work on advanced technologies in the future. And many domains have skill sets have developed in now the institutions. And it's very important to preserve us because it's a strategic asset for every nation. Very important topic which I would like to talk about is the Gaganyaan program, the human spaceflight program. I think all of you are excited to hear about it the recent times, and everybody talks about when are you really sending the first Indian to space. I think equally like you, I am also excited to look at the possibility. But all of you know Gaganyaan program has its own challenges. Building a rocket and launching satellites has its own risks that anywhere, anytime there can be a failure of a mishap happening in the rocket and the satellite falling into the sea. But when a human being is flying up there in a rocket, we need to make extreme care to ensure that the mission is very successful and there are no flaws in it. And if at all it happens, that we can even save the crew very effectively. So there are complex systems that comes into Gaganyaan program. And we are developing each one of them through systematic step-by-step process of uncrewed missions, robotic missions leading to the human spaceflight mission. I can tell you that this coming years, we are going to get ready for the first uncrewed mission, encompassing all those developments that we have been doing for the last 5-6 years of time. Many technologies have been developed, and I can tell you, my people, that these technologies are not available from others to us. It needs to be groomed and created within our knowledge and capability in India, using our own industries, our own knowledges. We have been working on it, and so I can tell you it's a huge challenge. And it's an invitation for young people to come and work in this sector in the future, as government has announced an expansion of this program, building space stations and going to moon, which I will talk about a little later. You know, the support that we get from our Honorable Prime Minister in human space program is enormous. He recently came to us and then showed the demonstration of how we are going to build our crew module, how the crew is going to sit inside the crew module. I think these are very interesting times. And also, we did a recent mission of the crew escape system, where a test vehicle, a liquid propellant-based test vehicle, took the entire crew and the crew escape system, and we intentionally aborted it. And after the aborting, the crew module has to come out of it, open its parachutes, and land properly, safely in the waters, where our ships went and collected it. I think it's the whole of this chain of events that you just see are the crux of the safety that we are bringing into the rocket systems, and this is very crucial. And this is for the very first time we are doing it in India. And we need to make it perfect after so many tests, and I can tell you that we need to have the systematic test programs to ensure that there are no flaws or there are no design-related issues while we do the final human space mission, maybe possibly by 2026. Equally important is while we work on reusable crafts like others are doing, the dream of flying an aircraft like rocket to space and then coming and landing on a runway has always been an imagination for each one of you. I think Space Shuttle demonstrated it. Space Shuttle was a launcher which was a partially reusable one, but it is discontinued. But unmanned, autonomous rockets that will go up to space and come back is always a dream. A lot of people are working all around the world, and we also have our own share of called a reusable launch vehicle demonstrator. Recently, we did some tests on it, and we are going to develop it, complex systems of going up the space, landing back. And it's very interesting that we did recently 2 tests of the reusable launcher, running down a runway, fully autonomous with its own computers and algorithms. And these reusable crafts just don't land like aircraft. They are moving at speeds almost double that of a standard typical aircraft that you see in runway landing. So you can imagine that it comes back from orbit. You face huge challenges. And this is something that we have just now overcome. And we are going to build a bigger craft where we will be able to send satellites or even put instruments and put to space, conduct experiments up there, and then bring back the experiment back to Earth and do some scientific studies specifically. Possibly we will be able to launch small satellites in the coming days using reusable launch vehicle. It's a huge technological gem that we would like to develop. While we work on all of these launcher capabilities, equally important is the science missions that we have been doing. The Chandrayaan series of mission, which started with the Chandrayaan-1, I think all of you are aware of Chandrayaan-1 journey, which was an orbiter that was launched using the PSLV rocket. The Chandrayaan-2, when it was ready for launch, our LV-M3 was ready. So I'm very happy that while I was working in that project, that rocket was made ready to launch the Chandrayaan-2 in its inaugural operational launch, which was hugely successful. Then the Chandrayaan-3 came, but Chandrayaan-2, of course, though the orbiter and lander were there, the orbiter working very well, the lander failed to make the soft landing. But the Chandrayaan-3 made history. After understanding the failure of Chandrayaan-2, we were able to correct and then make the Chandrayaan-3 land softly on the southern side of the moon. And this was a historic event on August 23rd, 2023. When the Honorable Prime Minister was lively, looking at the whole screen, and we were all looking at the screen with bated breath and heart, the lander softly touched on the southern side of the moon. It was a historic event for all of us. All across the globe, I know my friends and colleagues, they were all celebrating. And all of you, I know, many of you would have seen this event directly. I think this has changed the way the complex missions are handled by ISRO, where touching the moon, though we have done in Chandrayaan one time through a impact probe, soft landing on the moon is a huge complex problem. And after touching down, we need to achieve some fantastic science objectives. I think I'll talk about a little bit later. It's not just soft landing on the moon that is important. We need to do scientific experiments and then generate data for our scientists to understand about the moon and its other related issues. I would like to talk to you a little bit about at this moment and go back and look at how scientific output of these missions were hugely important for each one of us. We have a huge tradition in India looking at stars and celestial bodies, and the science of it's evolved over this nation, maybe many years back. And this knowledge is still preserved in some form or the other. But advancing the knowledge has not happened for many years. And it is the first time that we have a unique opportunity to work and contribute to the global knowledge of science. Chandrayaan-1 was the mission which gave the knowledge that there is water on the moon. And we are now further searching out that observation. And we have an Aditya L1, which is a dedicated mission to look at the sun and its interaction with the Earth by launching it to the Lagrangian point. We also launched a satellite called X-ray polarimeter satellite called EXPOSAT to look at black holes and its interaction with other stars. And these missions have produced not just the optics, is there not just for the optics or to show that we are launching them, but it produced very interesting scientific outcome which has got the attention of the scientific world. Recently, the publication that came out of the Chandrayaan-3 was very, very important with the mineral data and also the nature of the landing site. It is really noteworthy. Similarly, the observation from Aditya on ultraviolet spectra observations of the sun disk, as well as the recent solar eruption events, really were captured very well by these instruments, and this data is being supported, evaluated for further research and publications by the community. I can tell you that it's not these three satellites. We have earlier satellites like the AstroSat, which has produced almost 400 publications and almost 30 plus PhDs out of the findings of the AstroSat. So though the scientific research contributions in terms of the missions were small, but the outcome has been really surpassing the expectations. I would like to spend some little bit of time on the further developments that are going to take place in the space sector. A grand space vision for 2047 has been announced by the government. Honorable Prime Minister has made this announcement himself about how we are going to expand in the Amrit Kal, the activities in space sector, and the new vision that's going to drive us towards expanding space activity as well as space economy. With the backdrop of the Chandrayaan-3 landing on the moon, today we have an ambition to land an Indian on the moon by 2040. If you have to really achieve that, we need to make a lot of progress in terms of our ability in building future moon missions. The Chandrayaan series of missions must be continued to create capability. We should also build a huge, higher payload capable, reusable rocket so as to put these bigger satellites and missions possible. And we want to build a space station so that our human space activity can continue to do microgravity and related research, become an outpost at a certain point of time to move to moon. I think this chain of steps that we need to take to leading to the ultimate landing of an Indian on the moon has been defined as the grand space vision of 2047. And I would like to show you that this was announced by Honorable Prime Minister when we gave the wings to the astronauts. So the 4 of the astronauts who are getting ready to fly in Gaganyaan were given the wings by Honorable Prime Minister. And at that time, this grand vision was unveiled. And last year, this happened. And later, I can tell you that we have worked on this vision to convert his vision into actionable items. So recently, government announced the projects of Chandrayaan-4, which will go to moon and then bring back samples. Then the NGLV, the new rocket development, and also the first module of Bharati Antarisha Station to be developed and launched. I think this is something really wonderful, and we are taking steps to make his dream a reality and India to become a global space power in the days to come. But the most important element of doing all of this is the power of the rocket. We had the PSLV, LVM-3, and the SSLV, but they are capable of certain capabilities, typically around 4 tons to GOTO is our capability, which will be translated into approximately 10 tons to low Earth orbit. But to launch space stations or to send humans to moon, we need higher payload capability. Typically 30 to almost 70 tons of mass is to be lifted to a low Earth orbit. And this is possible only if you build heavier rockets. But then we cannot build rocket just for this purpose alone. We need to build rockets in such a manner it is sustainable. It will bring in benefit in terms of economic activity. We should be able to launch our satellites regularly, and we should do it in a commercial manner and a cost-effective manner. That's why we are developing the NGLV, which is shown here, which is a tall satellite, almost 90 meters tall, and 5 meters in diameter, which will be able to lift 30 tons to low Earth orbit. And this will be partially reusable as well, so it can bring down the cost of access to space substantially. And based on this, we have created a roadmap for the space sector. How we are going to develop transition from the current launchers to the future launchers and build space stations in an incremental manner, and then make the moon missions possible on a yearly plan has been prepared, and now we are working on each of these projects. And I'm very happy to tell you that this year, government has announced enough of our financial sanction for us to do all of this vision possible. And we are all excited in Department of Space and ISRO, and also to work with the new stakeholders in the private industries to build all of this in the coming days. Let me give you a little bit of glimpse of the elements of this mission. One of them is the Chandrayaan-4. Chandrayaan-3 demonstrated that we can go and land safely on the moon. But then taking off from the moon, getting into the orbit of the moon, then start from there and reach the orbit of Earth and then come back safely on Earth. It's a huge challenge. It is like launching once again from moon autonomously with nobody there and coming back. Of course, Americans and Russians have done way back, but then doing it today is still a huge challenge. And it is very expensive. So we are looking at how we can do a mission to go to moon and come back in a low-cost manner. And that's why we have developed a Chandrayaan-4 architecture, where many modules are made together. It will go to Earth orbit, it will dock, go to moon, de-dock, then come and land on the moon, take off from the moon, and then come back to the moon orbit and dock, then return to Earth, and then a small part of that will reach back to Earth with the samples drilled and taken and packaged from moon. Now, will it not look very exciting for you to such a complex mission to be conceived, built, and then made perfectly for us to launch? I think all of us wait for that event to happen. But all of us are excited in ISRO and many other stakeholders to design and develop this complex engine mission and make it happen by 2028. Equally important is to develop capability to build heavier crafts. I think the Chandrayaan-4 will be similar to Chandrayaan-3 in terms of the size and mass. But if you have to send human beings to space, think about a mass of 100 kilogram person to be taken there, or maybe 3 or 4 people to go up there. We need to carry heavier mass. That's why we are looking at a next series of Chandrayaan called Chandrayaan-5, where we will take a 350 kilogram rover. The Chandrayaan Pragyan was only 27 kilogram mass. Now we are talking about a 350 kilogram rover, and that to be taken to moon and land safely, and we would like to do it in collaboration with Japan. And we are working on a mission where a heavier lander will be built by India, and a rover will be supplied by Japan, and we will jointly do this mission using their rocket. And this is also one step towards reaching the manned mission goal. While we work on moon mission, it's equally important to look at other science topics of understanding other planetary system. We have done missions to moon, we have done to Mars. Now we would like to look at Venus. I think all of you know Mars and Venus are our sister planets. Earth is a living planet. Mars and Venus are dead planets. There is no life there. They are almost similar in looking like Earth in terms of the mass, slightly lower in terms of the mass and gravity. They have a beautiful characteristic. Their periodicity is similar to that of Earth. And here is Mars with its atmosphere 100 or even less than that of the atmosphere of Earth. And here is Venus, which has an atmosphere which is 100 times that of Earth. You know, it is much more thicker. It is sulfuric acid and heavy winds are blowing. Mars, here it is dry and dead and almost no air there. So we don't know why this planet's transition from a living planet to dead planet, and whether it will happen to us on Earth one day, that all this atmosphere will vanish and one day this will become a lifeless planet. And what are the processes that make it happen? I think this is scientific curiosity we need to understand. That's why people are going to Mars and Venus and trying to understand. And it's equally important to join many other nations who are trying to study this. And we are going to plan a Venus mission where we will understand as an orbital mission and put sometimes a probe into the atmosphere and do some measurements to look at some traces of new physics that can be explained. I am very sure that Indian ideas are always very interesting. That though people have been going to moon for so many years, it is the Indian mission Chandrayaan-1 found the water, and I am very sure about it. When you go to Venus, we will find something very splendid there. Now, while we do all of this, it's equally important is to work on the operational missions and of spacecrafts, which is important for the nation. I am not going to explain each one of them, but then you know that we have a huge array of communication satellites that we need to build. We have built and operating many of them, as I told already, and we are building future communication satellites to support this sector. But this communication infrastructure today is moving from the government operated to private operations. So NSIL, the New Space India Limited, is operating 10 of our communication satellites, and future satellites will move over to them. But we are building some for our regular users like the DTH providers, as well as our special users, which are our strategic users. We also work with many international customers to build our satellites in communication. And communication is again a complex area where it is revolution is happening. It is not just limited to geostationary orbits. All of you are aware that LEO communication constellations are coming up of other nations, and we are looking at various models how to expand communication infrastructure. Equally important is the infrastructure related to the Earth observation satellites. Earth observation satellites are eyes from the space. If you look at land and stand here and observe, you can only see a certain extent. But when you go up in the sky and look with using a camera, you can see a very large view, you can get a real good observation, and not like a human eye, but these eyes in the satellites are having different spectral characteristics. It doesn't see with the natural light that we are seeing. It can see beyond our visible spectra, thermal, infrared, ultraviolet, X-ray, or radar observations. And this allows you to look through the clouds, you can look through day and night and make so much of information that a human eye can ever decipher. So that's why satellites are very important. And we can put satellites of various kinds, and we have been building and launching the world-class satellites, which is helping us in terms of resource mapping and also strategic information. And we are going to serve this sector very well in the coming days. And this is happening not by ISRO alone. This is happening because the stakeholders with us, the ministries, departments of Government of India are working with us in various ways. They fund us, they put the demand in front of us. For example, agriculture tells us we need to look at the crop mapping, we look at the drought situation. The Ministry of Earth Science say, I need to understand the water resources, I need to understand the oceans. The Ministry of Environment talks about the climate and the related issues, and we design and build the satellites for these users. And we make them part of this journey. That's why we are having these special satellites coming up, complex satellites which are designed and developed by India. Equally important is the working that we have with the other stakeholders, other space agencies. For example, the one which we are building with the US, the NASA ISRO synthetic aperture radar satellite, one of the costliest satellites ever built by anyone in the world. And this satellite is a two-band synthetic aperture radar, the L-band and S-band. The L-band comes from the US, the S-band is coming from India, and we integrate it into a single payload. And the bus is built by ISRO, and we launch it on a GSLV rocket. And the satellite is just now at Satish Dhawan Space Center getting integrated. Possibly the launch will take place early next year. So let me talk a little bit about another interesting satellite called SpadeX, which is going to demonstrate the docking of satellites in orbits. You know, if you have to go with a human spaceflight mission and then enter into a space station, you need to go and connect it. Possibly you would have watched some of the docking videos that are available outside. And this shows that it's a complex process. Come very close to it without causing large movements, very precise movements autonomously, and the computer will move the craft close to the mother craft and connect them physically. And then finally you can seal the interface and move from one compartment to another. This docking is a complex process, and we would like to build it and launch it in the coming days. And these satellites, I can tell you, it is already ready, and we are going through a final testing, and launch will take place in this December. And we will be launching in one PSLV, these two satellites. They will move apart, a kilometer apart, and they will come closer and dock to show how we can do this autonomously. We are also working on the other technologies which I mentioned, the quantum key distribution. You know, in the coming days, the communication links are subject to spoofing and other entry of other unauthorized operators, and how to encrypt so that others cannot come and look at our communication network. For that, a quantum key distribution is one solution, and we are going to launch 2 satellites which will send these quantum keys using the quantum technology that we have developed within ISRO, so that these communication channels will be encrypted using that. No ordinary computer can ever break that code. So we will have a secured communication. So I mentioned about the software-defined radio satellite as well, which is the one which is very important for us in the coming days. Let me slightly dwell on another topic called navigation. Possibly all of you are aware of the GPS using which your devices are connected, and you can get the position, the timing, the speed, etc. I don't know how many of you are aware that we have a NAVIC system which is called the IRNSS, where the national timing distribution is also happening through NAVIC today. And we have a precise timing system, and we created this timing information dissemination as well. It also has a different architecture. It is not exactly like GPS. GPS is a global system, whereas NAVIC is a regional system. And the satellites are in geostationary orbit and nearly stationary. So it serves the Indian continent and also some areas around it. And this is much more accurate than GPS, but it uses a different band called L5 and S band. So that's why your mobile phones cannot easily see it. But we are now putting the band called L1, which your mobile phones will be available. And we have just put only 1 satellite. In the coming days, we are going to put 5 more satellites in L1 band, which will make your mobile phones easily possible to use our NAVIC signals for positioning services. And currently, these are very important for our strategic users to control their assets, etc. Some of the civilian uses, I would like to tell you, these satellites are very important to, for example, the real-time train information system. This is integrated through this satellites. It not only provides you the position, navigation, timing services, you can also send messages. If you want to send messages to one region of the country, we can send it through that satellite. 4 of our satellites are doing this messaging services, and we do this for railway connectivity, and we also can use it for collision avoidance of unmanned railway trackings. And we have also covered this with almost 8,700 locos have been covered, but we need to put it in more locos in the coming time. Yet another service that we are doing with this navigation satellite is vessel communication. You know, when fishermen go out into the sea, they don't have connectivity to mobile towers. And how to communicate with them? Either you need to use satellite telephone, which is very costly and everybody cannot afford. Their location need to be tracked. So we have now going to deploy a certain vessel communication infrastructure where they can do bidirectional communication to land using this navigation satellite. And they can get alerts. Suppose they cross their border, if there is a sea state changing, and if there is a cyclone coming, you know, if they are able to send messages to them, their lives can be saved. And they can also be informed about the fish catch, where it is going to be available. We have a fish advisory. They can also trade the fish they caught using an app that we have developed, which is put in the mobile. And this deployment has just started. Thousands of such devices have already been deployed in the coast of Tamil Nadu. And there's a plan to deploy almost 1 lakh such devices across the fishermen community all across the country. We talked about great technologies today, building rockets, satellites, and applications, and deploying equipments. But finally, the applications are the key to the purpose of the whole of this is to deliver applications and finally become useful. It should serve the community. It should create a business. It should create support the ecosystem. Let me talk about a little bit about the application domain, which could be interesting for young people, that there is a huge possibility with the talent in India, how the images, the communication capability, the navigation capability can be very well used for creating a business case for us. For us, look at how we are rolling out the Pradhan Mantri Fasal Bima Yojana support system through satellites. How to support the insurance of agriculture-related activities using remote sensing. And we have connected to the Agriculture Ministry and Department to create this support system through the satellite images. Now we can support lending as well as insurance support areas in some parts of the country. Similarly, we do mapping of the satellite-based crop mapping system using automated machine learning SASIA, and this is based on a radar imaging satellite time series processing. We do it, and this is deployed in some part of this, and data is also available in one of our portal called Bhunidhi, and we will be expanding this case in the coming days. Krishi Decision Support System is another interesting application specifically focused on agriculture domain, where we create crop radius maps. We look at yield estimates for at least 5, 6 to 7 crops. Then we look at the various elements that contribute to agriculture, for example, the weather, the soil, the crop signatures, the groundwater, and also we do the damage assessment in case there is a drought, etc. And this information is very much essential for our ministries and department to work on agriculture. And I can tell you that we are even looking at how to build a agriculture-specific satellite called AgriSat in the coming days. Agrometeorology is another domain. So meteorology means the weather and the climate-related impact on agriculture is another important. For example, the light that you are receiving, the insolation, the sunlight, how much it is falling on earth, and what is its intensity across the area. How much is the land surface temperature? How much is the evaporation that is happening from earth, and compared to the real evaporation. And this meteorological information becomes important for us to understand whether there is going to be a drought and what type of watering need to be done and how this is affecting the agriculture product. This is one support that we are going through space. Equally important is to look at how the disasters are handled using space. Recently, the Dana cyclone came and up to the Odisha, and you would have watched that it died away, and we have been giving information along with the IMD on real-time information using space-based data. And many of the cyclogenesis, its tracks can be tracked, and using computer simulation, we can find out when it will make the land impact and what type of damage that it can really cause. It's something very phenomenal. The space has changed the way we look at disasters, and lives are served using these technologies in a big manner. Look at forest fire. I think we have large forest cover in India, though it is need to be managed. I think today the Forest Survey of India looks at it in various ways to manage forest, its extent, its encroachment. But one of the important issues is the forest fire. Forest fire observation using satellite is something which is very easy because the fire has a signature, the infrared signature. You can take it from satellites, and if you know that there is a signature of fire, you can inform the Forest Survey, and they will be able to act on it. You get the geolocation, and they can send a team to quench the fire. And many a time, sometimes you get a wrong indication also because fire is like that, you can have thermal signatures. But mostly, we have very good signatures, and forest surveys today fully trained to handle the forest fire information coming from space. I can tell you there are tens of forest fires every day happening in India itself. Look at landslides. Landslides are equally an important problem. And ISRO has brought out landslide maps across many places where there are steep hills, and whether there is a heavy rain, climate and land create a combination where landslide can occur. But unfortunately, today we do not have real-time warning system for landslide, which is something that we all aspire to have by putting sensors. But then landslide need to be predicted, it should be mapped, and post-landslide, if it occurs, damage assessment happens, and reconstruction support we need to give. This is another important support that we give through space satellite. I would like each one of you to look at this website called Bhuvan sometime. And some of you may be aware and some of you may not be aware about it. Bhuvan is a geoportal of India. We are created using our own satellite data mostly, having many thematic layers, almost 200 plus geospatial applications, and it has specific data for each of the states, central ministries. You can look at drought, flood, glaciers, and many other data on a real-time basis whenever it occurs. So I advise you to go to and search for Bhuvan nrse.gov.in to understand more about it. And many of these features are free for you, but there are many other features which are not available if you should become a registered user for it. And we have been working on it over so many years. It has huge amount of data sets about the national assets which are natural assets, and also assets that we have created like the construction system, the heritage sites, the islands, and many other features. So I invite you how satellite data and along with other data sets, you can create a geospatial repository, a huge one for our nation. I think each one of you should look at it and promote it for us to make more meaningful value out of it. And we also are looking at how this data can go to other industries and startups to make more value-added products out of it. Using the space-based data, we have been looking at national disaster management. The NDEM version 5 has been recently released by ISRO to the Ministry of Home Affairs. This is a single portal where all disasters happening in India are portrayed regularly. And we pick it from various sources, which include satellite data, terrestrial data, and many other information, and it is all put in one place. And if you go to NDEM portal, possibly this is done only in the supervisory level, and we can look at various base layers of this are built using satellite data, and we add it up with various additional information coming from space. Yet another information is the National Information System for Climate and Environmental Studies, NICES. And this is also an interesting area. Those who are interested to work on environment, climate, and climate change related information, essential climate variables. There are 50 plus of them which are important for you to help in climate modeling. And almost 50% of them can be observed using satellite data. And today we have almost 12 to 13 of them observed using satellite data. And this we continuously generate and put it in our website. And researchers across all the modelers of climate and weather use this data and produce outcome. This is one of our mandate to produce and deliver it using various data. This includes color, land temperatures, for chlorophyll content in earth, cloud cover, the moisture content, lightning, ocean current, snow cover, many other data. Such data is regularly updated by us. Let me tell a bit about, before I close and conclude, I need to talk about a little bit about our reforms in space sector, which I started to talk about in the beginning. The impact of the space sector reforms in 2020 has been phenomenal. Today, while we had only one startup in 2014, today there are 200 plus startups in space sector working. There is a new policy called Space Policy 2023 has been announced. A new foreign direct investment policy has been announced by government. A new geospatial policy came out. All these are adding to creating a more vibrant space economy. Today, our aspiration is that India's contribution to global space economy is hardly 2% today. We would like to expand it to something like 10% in the coming 10 plus years. To make it happen, we need participation of many other stakeholders. We want startups, we want big companies to come into space and contribute to create a vibrant space ecosystem. And we creating those enabling mechanisms of companies working with ISRO. We want to give the technologies to them, allow them to build complex systems like rockets and satellites, create applications for delivery, and a lot of industries are showing great interest in investment in this sector, and this is a huge expectation that we have today. To enable this transition to take place, we are handing out what we have been doing traditionally in ISRO to the industries, like rocket building. Can you imagine that rockets were built only by ISRO? Now we are going to have rockets built by private companies and launched in India. This is happening elsewhere, but it has to happen in India. And if it has to happen, we need to empower these companies. And we started with the PSLV handing over to the big industry giants. We have opened the SSLV for a technology transfer, and companies have quoted for it. And we also want our LVM3 to be produced using a public-private partnership model, and this which is also announced. And these are steps that we have taken to empower these companies to come into space. InSpace is doing a phenomenal work today to support all the startups and all the new stakeholders in terms of the numbers. It is very good, the type of authorization they have been giving, the technology support they have been giving, the mentoring they are giving, the funding, seed funding they are giving. Recently, the government of India has announced a 1,000 crore VC fund for private companies to come into space. Where this being the space sector being a high-risk company, many investors hesitate to fund this sector. So once we have a government-sponsored funding supporting new startups and companies, I believe that the new investors will have more confidence to come and support these companies to come into space sector. It's something very phenomenal thing happening in the space sector. The space policy also has seen how our data is being used. The space data today, which is used free today. Today, the data up to 5-meter resolution that is coming from satellites are free for you. I think many of you may not be knowing that if you really want to access this data, up to 5-meter resolution, you can get this data and use it to create additional value-added products, especially in the domain of infrastructure building, imaging, value addition, etc. You can use it, and private companies can access it free. Only from 5-meter resolution to lower resolution, you need to pay certain nominal rates, which is also available to you. So it's a major change in terms of the policy that we have brought in, and the value of the data that has been soaring, the downloads and other access has been soaring in the recent times. Let me also tell you a few more points for you to understand the ecosystem. One of them is the dependence on imports for space program. Atmanirbharta is important for space. Nobody should choke our program in no way. So we have been working on indigenization in a big manner in the last so many years. We have brought down the dependence of raw materials and materials for building our rockets and satellites substantially, but still critical items still comes from outside. We need to work continuously. If you have to build our own ecosystem, never to be constrained, I think we need to put effort, and this is one of the steps that we are taking. We also work on advanced R&D in many ways. Almost 1,000+ R&D activities are taking place of developing new technologies in ISRO. It's just not building rockets alone, but the fundamentals that goes into building rockets and satellites are also happening in terms of sensor technologies, in terms of orbital fueling. Some of them I have already mentioned, but many of them are not mentioned, which is also very interesting. For those who are interested to look at it, we will give you more access to this information through our websites. Another interesting area is that our technology, which are developed using public funding, the government money, is for you to use. We don't want to control it and keep it within ISRO. They are available for technology transfer to industries if you really want to monetize and use it to produce products and services. We have been working in this area for long. Almost 400+ technologies have been transferred. We are working vigorously within space and NSIL to transfer more technologies that can be used by companies, which involves the lithium-ion batteries, supercapacitors, even satellite bus, even rockets are available for you to technology use only for Indian companies. And we also have softwares and related technologies are available to you to develop complex systems as well. So let me conclude my talk to tell you that our ambition is to travel from Earth to space with more Indians on board. The Gaganyaan program is an ambitious program. The rocket has just taken off in its first journey, and we are waiting for it to separate in orbit and send the humans to a safe orbit so they do the work there. And then after the research work which they are done there, they will come back and land safely in Indian waters, where our ships and aircrafts will go and pick them. And this is not just a dream or an animation that I am talking to you. This is something that is going to happen as a reality. And after that, we will be building the space station to go and create our Bharati Antarisha Station, and there we will have regular access to space and leading to us to land on the moon one day. And these days are not far away. I think all of us in ISRO, the Space Department, are excited to work on this complex technology. And I share the same excitement and happiness that we have today to build these complex systems with Indian mind. And I can tell you that when Chandrayaan-3 landed, we were all proud of the fact that the Chandrayaan-3 was built using our knowledge and our skills, and it tried on an Indian rocket. When you talk about Sardar Vallabhbhai Patel, who emphasized the strength, and we are also reflect that same spirit of doing it ourselves, not just to boast about it, but to do incrementally, cost-effectively, to build the capability within this nation. And it also to become an inspiring organization for us to emulate in many, many other sectors. For Bharat to become a powerful nation tomorrow, we need technology support. Just not space is going to help us. In many, many other areas, we need similar growth and expansion. Could it be in electronics, it could be in agriculture, it could be in industrial production. There are many, many other areas there we need to invest and create capability and competence. And we have it in India. We need leadership. I think that is what is being given by our government today to transition from an aspiring nation to a progressive nation, a leader whom everybody will aspire to come and stay with us. Thank you so much for this opportunity for this talk.
I now request Dr. Pragya Paliwal Gaur, Director General Akashvani, to propose a vote of thanks.
Namaskar. On behalf of Akashvani, I express my sincere thanks to each one of you for making this year's prestigious Sardar Patel Memorial Lecture 2024 successful and fruitful. I begin with expressing our heartfelt gratitude to Honorable President of India, Srimati Draupadi Murmu, for gracing this occasion with her special greetings. Her insightful thoughts have been truly encouraging for us. The grace that Madam President has lent to this year's Sardar Patel Memorial Lecture is a blessing to our institution in more ways than one. Your kind participation in the event has certainly made a positive difference to each one of us here. It is indeed a rare, gratifying moment for Akashvani. We extend our deepest gratitude to Dr. S. Somanath, Chairman, Space Commission and Indian Space Research Organization, for his illuminating words on Indian Space Odyssey and the path forward. Sir, your thought-provoking address has provided the audience precious insights into a challenging yet fascinating subject. I am sure that many questions orbiting in the ignited young minds present here have been answered. Your lecture has been inspiring to one and all, and I must say it was a special moment in the long journey of our institution. I am grateful to Shri Navneet Kumar Sehgal, Chairman, Prasar Bharati, for his kind presence and support throughout as a patron and mentor in making this event more meaningful. I thank Shri Gaurav Dwivedi, Chief Executive Officer, Prasar Bharati, for his gracious presence and for being an inspiration for us during the preparations of the event. I am also thankful to each and every member of the audience present here, especially students, for whom this will always be a cherished memory. I express special thanks for members of the press and media whose active participation will surely enable wider dissemination of today's illustrious and stimulating lecture. Also, special thanks to Doordarshan for facilitating the recording of the message of Honorable President of India. My heartfelt appreciation for staff members of Akashvani, especially the organizing team of this event, who left no stone unturned to make this event successful. I conclude with the hope that the precious legacy of Sardar Patel Memorial Lecture Series continues with the same fervor year after year. Last but not the least, I express gratitude to our esteemed listeners who look forward eagerly to this oration year after year. Thank you.